Hi, it's Moser with another tutorial. This is number 13 on the 4B worksheet from your Holt Physics book, book problems worksheet. The largest squash, we've got a giant zucchini or a pumpkin or something, and you are going to push that pumpkin, let's call it a pumpkin, up a smooth ramp 6 meters long that makes a 30-degree angle with the horizontal. You're given the applied force of 2,080 newtons up the incline. We want to know the net force, the net acceleration, and the time required for the squash to get to the top of the ramp. So as always, we'll start with a free body diagram. There's the basics. We have the force of gravity, we have normal force, and an applied force. We're not really going to need normal force, but I put it in because it's a good idea to get used to doing that. And remember that since this is on a ramp or an angled surface, we have to split the force of gravity into a force of gravity on the x and y. And just in case you've forgotten, I put in the fact that Fg sub y is equal to force of gravity times cosine theta, and Fgx is equal to Fg sine theta. Okay. Now, probably more out of habit than anything, I've gone ahead and done the sum of forces on the y-axis, and since the pumpkin doesn't seem to be levitating or crashing through the ramp, then it's all the forces up minus all the forces down, which is normal force minus force of gravity on the y. But it's zero. Well, the important thing that tells us is that any net force on this pumpkin, we could say, is on the x-axis. So that's where the real adventure is. So I've gone ahead, and though we've been starting with sum of forces on an axis equals mass acceleration, I've gone ahead and started off with sum of forces on the x equals the applied force minus the only force acting in opposition to the applied force, which is the force of gravity on the x, or Fg sine theta. Well, as I said, that's actually equal to the net force. So when I solve for that, F applied minus Fgx, I'll actually have net force. Now, lest you think I've forgotten it, sum of forces on the x is also equal to the mass times the acceleration. So we can take that, set mass times acceleration, equal to F applied minus F of gx, and then it's a pretty easy solve for the net acceleration by dividing both sides by mass. Fantastic. Now, when you get to part C, well, that's just a kinematics problem. Straight line motion, where you know acceleration, you know initial velocity, and you know distance. I think you can find the time. Have fun!